Hey guys, today we'll be looking at the sixth part of the problem 2.3 from the book Mechanics of Materials 6th edition by James M. Gear. Here the question states that a two-story building has a steel column AB in the first floor and BC column in the second floor as shown in the figure given. The roof load P1, which is equal to 400 kN, so here P1 is given as 400 kN and P2 is given as 720 kN. Each column has length L as 3.75 meter, so we know that the value of L is 3.75 meter. The cross-sectional areas of the first and second floor columns are 11,000 millimeter square and 3,900 millimeter square respectively. So here we have also been given the cross-sectional areas of the first and second floor columns respectively. Now here the question is asking us in the first part to assume E as 206 gigapascal and determine the total shortening AC due to the combined action of the loads P1 and P2. Now let's look at the solution. Here we have been given all the known datas and also the figure. Now here we know that the shortening delta AC of the two columns, we know that the formula for delta will be equal to the summation of NI-LI divided by EI-AI, which will be the sum of the AB section and the BC section. So we'll have to add both of them, and here we have to substitute the values known to us. So after substituting, we finally get the value as 3.7206 millimeters. So here delta AC will be 3.72 mm. We take the first two digit after the decimal. So this will be the shortening due to the loads P1 and P2, which comes out to be 3.72 millimeter. Now in the second part the question is asking us how much additional load P0, this is P0, can be placed at the top of the column, which is point C, if the total shortening AC is not to exceed 4 mm. So here we know that the delta AC max is given as 4 mm, since the question has told us that the total shortening AC is not to exceed 4 mm. So here we know that delta naught will be additional shortening of the two columns due to the load P naught. Here we know to find out delta naught we have to minus delta AC from delta AC max, which is 4 mm, which comes out to be 3.7206 mm, the value of delta naught. So here we have the expression by using the formula of delta P0L divided by EAAB plus P0L divided by EABC. Here we take a common P0L divided by E, and this is what is left inside of the brackets. Now after solving for P0, since we know other values, we get the value for P0 as 44,200 Newton, which is also equivalent to 44.2 kilonewton. This will be the additional load P0 at point C. Thank you very much. For more questions, comment down below.